Okay, so where were we?
So we just realized that there was a slight error in
Right.
in our calculations. So it's actually of radius 5.
Okay.
So the area of the semicircle is actually 25 pi over 2.
All right, so now we got 25 pi over 2. Minus 24. Okay? So that's the area of the two blobs together. Just like in the last problem, finding the area of that blob all by itself, each individual blob might not have been so easy to do, but finding them two together actually wasn't that hard to do.
Now let's find the area of the triangle, because
Okay.
we need to subtract that eventually. So it's 6 times 8 over 2, which is 24.
Okay. So this is the area of the two white blobs. This is the area of the triangle.
And now we can find the area of the semicircles.
Okay.
So this one first.
Well, it's pi r squared for a circle, and the radius is 3.
Okay.
So that's going to be 9 pi, because pi r squared, 9 pi, and then for the semicircle over 2.
Okay. So 9 pi over 2 is this semicircle here.
And then
And we have 16 pi over 2, because we have a circle of radius 4.
Okay.
Well, because I was thinking of leaving it over 2 so we could add these two together.
Okay. Good idea. 16 pi over 2.
Well, that's
25 pi over 2.
Oh, interesting. So the area of the two semicircles together is 25 pi over 2.
which was the area of this semicircle here. Because we can see that because if you fold the semicircle out,
Uh-huh.
it's the other one on the triangle.
Okay. So now that we know,
So we have to subtract the total 25 pi over 2 minus the area of both blobs.
okay. So we have 25 pi over 2 minus
25 pi over 2
Minus
oops, sorry, I wrote pi before I wrote pi. 25 pi over 2 minus 24.
And so with the multiply the minus through, these go away, and you're left with the 24.
Plus 24. Which is what?
Which is the area of our 6, 8, 10 triangle.
How about that? So your idea to work with a simplified case first showed that it worked. So what do you think the general case is going to be?
Well,
maybe we could use it for like x, y, and z, where they're the sides of the triangle.
Very good. And what do we know about the relationship between x, y, and z?
Well,
x squared plus y squared equals z squared.
Interesting. And I'll make the same suggestion I made before, just to make the arithmetic a little easier. Instead of picking x, y, z, let's pick 2x, 2y, and 2z.
So it looks like it maybe won't matter as long as x, y, and z are Pythagorean triples. It looks like it might not matter.
2z, 2x, and 2y. Okay? So what is the area of the semicircle?
well, it's it's z over 2.
It's z squared times pi over 2.
The radius of the semicircle is z.
And then, so it's pi times the radius squared. So pi times z squared.
Uh-huh.
And then over 2, because it's a semicircle.
Pi z squared over 2. In the area of the two white blobs, we have to subtract out the area of the triangle. Now we got a leg 2x, a leg 2y. So what's the area?
It's 2xy.
Okay. So minus 2xy. So we get pi z squared minus 2xy. Again, the area of the triangle is just 2xy.
And then we need to find
The area of the other semicircles.
which, well, that would be, well, since we have the 2x and 2y, you could just replace the exponents, and for this larger one, you could replace z with an x, and
Okay, so what's the area of this semicircle here, the whole semicircle?
it's pi times x over 2. pi times x squared over 2.
Pi times x squared over 2.
And pi times y squared over 2.
So I get the area of the two semicircles together is pi x squared over 2 plus pi y squared over 2. And then I have to subtract
The
area of the blobs away from that, which is pi z squared minus 2xy. So what happens?
Well, we have a pi x. Well, if you ignore the pi over 2's, you have an x squared plus a y squared and a z squared.
And so I'm subtracting the z squared, right?
So that's that. All that is going to go away.
And then I have a minus times the minus 2xy, so I'm just left with,
2xy,
which happens to be,
the area of the triangle.
how cool is that?
oh,
So the neat thing about this is you have a shape, a very curvy looking shape there, plus a very curvy looking shape here, and the area doesn't seem to have anything to do with pi. Pretty surprising.
yeah.
All right, high five, guys. Pretty fun problems. Good,
Yeah.
good work.